All right, so unfortunately, since I can't bring the demos to the class, I have to kind of do them outside, at least something that's kind of interesting. So what I have here is what's called the Van de Graaff generator. So this is actually just a piece of felt, which is attached to a motor down here. That's gonna cause this thing to spin, and then up inside of here, inside of this globe, there's basically just little teeth that are gonna strip off electrons, causing this thing to become negatively charged. Okay, so basically what will end up happening then is this thing's going to become negatively charged, but as we talked about in class, there are loose charges in here, so I'm then going to get a repulsive force between the two of these to then create an electric force. Go ahead and turn this on. So here you can see the hairs starting to stick up. This thing will actually start to increase, so it'll actually start to stand up. But what's actually more interesting about this is the fact that what's really happening is this thing is creating an electric field, which means that this electric field, due to the fact that this is being negatively charged, creates then a electric force onto here due to the fact that I have charge inside of here, so charge in the presence of an electric field manifests itself as an electric force. Now I'm going to do the same thing with this light bulb here. So basically inside of here, there's a metal, i.e. there are electrons inside of this metal. So here I'm going to create, again, an electric field, and then I'll hold this guy near here, and then you should, hopefully, depending on how much light comes from the computer, see that this thing actually lights up. So give me just a second, let me turn off the lights here. Good, so now we have our mood lighting on. So again, I'm going to go ahead and turn this thing on. There's the switch. Good. Go ahead and turn this guy on. So this thing again is generating up. So now if I put the light bulb near here, you can kind of see it. You can then start to see the electrons inside of here actually being accelerated, causing the light then to come on due to this thing being accelerated. So it turns off that electrons give off light when they are accelerated. That's why we have things like light bulbs which actually work. But again, here what you're seeing is the manifestation of the fact that this thing is creating an electric field, and then I have the charges inside of here, so that is then creating a force onto these charged particles. And if you notice, down in this portion actually was the brightest, and then as it went up, it actually kind of decreased in dimness, and the reason for that, again, is that the force, the further you get away, actually reduces, becomes less. So the ones down here are feeling a greater force, so they have a greater amount of acceleration, meaning they're giving off more light, because as I talked about, actually it turns out that light is due to the fact that we're accelerating charged particles. And then in this range, as it goes up, the force is decreasing, which means that there is less acceleration, so there's less light, which is actually given off. So again, the only thing that's happening here is I'm creating that electric field. That electric field then is interacting with the charged particles inside of here, causing them to accelerate because they were feeling a force. So the force then is the interaction between the charged particle and then the electric field, and the electric field is generated due to the presence of the charge onto this globe here. So anytime I have a charge, I then have an electric field, which then permeates throughout all the space. And then forces are then the interaction between a charged particle and that electric field, which is created by another charge.